Today we're going to be talking about some basic differentiation rules and rates of change. So, some basic rules of derivatives. Derivative of a constant is zero, because if you think of a slope of a line that is a straight horizontal line that has no slope, or it has a zero slope, I should say. Now the power rule is you take your power, bring it down in front, and reduce the new power by 1. So you no longer need to use the definition of the derivative unless I tell you to find the derivative of a function. Constant multiple rule, you can kind of bring the constant out in front of any function, and then you can take the sum and difference. You can take the derivative of each term individually. So applying that rule now, if I need to find f prime of t here, that becomes negative 4t plus 3. If I need to find the derivative of f of x here, I'm not going to find the derivative right away, because what I'm going to do is I'm going to recommend you guys do this. I'm going to recommend that you guys write this as x to the 1/4 power. I'm going to recommend you write this as 7x to the negative 5th. Trust me, that's going to help you out. Because now when I want to find my derivative, bring down your exponent, reduce your exponent by 1, I get negative 3/4. Bring down your exponent, reduce your exponent by 1. Bring down your exponent, reduce your exponent by 1, so it becomes a negative 6. Okay? So I recommend any fractional or any negative exponents, you write those as fractions and negatives. Also, you can leave it like this. You don't have to worry about rationalizing or putting these negative exponents in the denominator. You've kind of, by getting here to calculus, you've proven that you know how to do that. We don't need those algebra skills from you guys. We need you guys to be able to apply the calculus now. Okay, next example. Writing the equation of the tangent line of that graph at 8. So first I need to find f of 8. So the cubed root of 8 is equal to 3. So to write the equation of a tangent line, to write the equation of a tangent line, to write the equation of any line, you need a point. Well, that point, 8, 3. And you need our slope. What's our fancy word for slope now? Our fancy word for slope is derivative. So we have our derivative of this function. First, I'm going to write it. I'm going to be a good model of what I want you guys to do. Write that as x to the 1/3. So now when I'm finding the derivative, I have 1/3 x to the negative 2/3. So then, now, I find f prime of 8. So now simplifying this, well, remember it's going to be a fraction. Take the cube root of 8 first, which is 2, then square it to get 4. So that equals 1/12. Remember that that is standing for our slope. Also remember our point slope formula. That's the formula that I want you guys to use. That is you can use other ones, that's fine, but this is the easiest one because it gets you the answer right away. So y minus y1, the y coordinate is 3, the y coordinate is not 3, Mrs. Marnell. The y coordinate is 2. I'm sorry, I'm a little flustered. If you're watching this video in 2020, we just had the first day of school. And though I did this problem, I didn't check my notes. And I'm flustered because the video that I just did, the one after this, I'm waiting for it to upload to YouTube, so I'm hoping it works. Okay, I apologize. Sidebar. 2 1/12 x minus 8. Okay, so that's now your answer for that one. We also want to find the derivatives of sine and cosine. So I want us to use the definition of a limit, definition of the derivative, which is a limit, to find the derivative of sine. So our definition of the derivative, remember, is this. So now I want you to still be writing these limit notations. So sine of, I can't write today. It's because I'm flustered. I'm not flustered. I'm just trying to go too fast. So you have to use your sum and difference identity. So sine of x cosine h plus sine of h cosine x minus the sine of x. Now, who remembered that? Limit as h goes to 0. Now, I'm going to rearrange the terms a little bit. Since I'm doing the limit as h goes to 0, I'm going to group these that have the sine of x together. I'm going to factor out my sine of x. I did that in my notes too. Okay, that should be a plus sign. Okay, ooh, this is all over h. I apologize. I am not doing well today. I apologize. I'm recording these new because of our new book. And now I'm going to do what I want to do. Okay, so I'm going to break this up into the sine of x times by the limit as h goes to 0 of the cosine of h minus 1 all over h plus the limit as h goes to 0 of, oh, I ran out of room. Oh, I should just restart. Sine of h times by cosine of x all over h. So let's look at a few of these limits. Let's first look at this one. Well, what does this limit go to? That goes to the sine of x. What does this limit go to? That goes to 0. And I'm going to rewrite this limit over here just because I think it's important for us to see what I'm doing. That I'm breaking these up into these two terms. And that's going to be cosine x. So this first term, these simplify to be 0. This limit here goes to 1. This limit here, well, because there's just an x, it's like a constant, it is that constant. So the moral of this big story here is the derivative with respect to x of the sine of x is the cosine of x. Now, what I want you guys to do is I want you guys to do this one on your own in your notes. I'm not going to go through this in the video, but I'm going to give you the answer on the next slide. but I want you to try it on your own. I think it's an important limit for you guys to be able to find. Okay, so we learned on the last two slides that the derivative of x with respect to x, derivative with respect to x of sine of x is cosine x. The derivative with respect to x of cosine x, hopefully you got negative sine x. And if you want me to go through that with you, I can. I'm more than willing to do that, but that's what you should have gotten. Okay, the first one here. The derivative of this is equal to derivative of sine is cosine. I could just take the 4, derivative of sine is cosine x, and we're done. Next one, the derivative. 7/5 is like a coefficient. Derivative of cosine is the negative sine of x. Make sure I can see that negative sign. Make sure it's very apparent to me. And then the last one, dy dx is equal to, so this is like having a 1 up front, so it's really like 1/9. Derivative of sine is the cosine of x. Now be careful here, what is this? That's a constant. So this is my derivative because my derivative of my constant is 0. Now they throw another another derivative at you, the derivative of e to the x. And we're going to, again, use the definition of the derivative to solve that also here. So I'm going to do the limit as h goes to 0 of f of x plus h minus f of x all over h. Remember, when you add your exponents, it's like multiplying. So I'm going to factor out an e to the x. So now up here, this is really like saying the limit as h goes to 0 of e to the x times by the limit as h goes to 0 of e to the h minus 1, that's not in the exponent, all over h. Well, that limit is 1 because we have that little hint there. So the limit as h goes to 0, since there's no h there, that limit is just e to the x. So what did we just learn? d dx of e to the x is e to the x. Now the derivative of d dx of a to the x is slightly different, but it's very similar. A to the x ln of a. Okay. That's a fun meme. I'm kind of known for memes. So there's our meme. We have a wild exponential function. Use differentiate. It's like the superpower or whatever. It's not very effective because you get the same thing back. That's why I kind of like e to the x. You get the same thing back. It's actually kind of fun. Okay, so finding the derivative now. What I'm going to do is I'm actually going to draw a little line here. And I'm going to put derivative over here. I'm still going to have good notation. So f prime of x is equal to, well, I can just carry the constant along. Derivative of e to the x is e to the x. That's why I like it so much. And then I have x times e to the third. E to the third is a constant. So that's really like saying e to the third. Now that's different because it's different than when it was like the cosine of, what was it, 5 pi over 3. That was just standing alone. There was no variable attached to it. It wasn't a coefficient. Versus here, that's like a coefficient. I just put it on the back to confuse you guys. Now I take the derivative of this. So 4/9, I bring down the 2, 8/9 x plus 5 e to the x. Now another derivative. Derivative sign is the cosine. Derivative of 2 to the x is 2 to the x ln 2. Okay, a little bit about particle motion. Particle motion is one of the biggest applications that we have in calculus. It's kind of almost guaranteed you're going to have an AP question having to do with that. So we have a particle moving along the origin. Its position function is typically called s of t. I don't know why. And it says it right there. So moves along certain amount of change. So the rate is equal to distance over time. Remember this? Distance equals rate times time. I just solved for r. Okay? So rate is your change in distance over your change in time. Said another way, it's s of, say if you're trying to find the average velocity of a function over an interval, it's s of b minus s of a all over b minus a. The instantaneous velocity is the derivative of position. Okay, so instantaneous happens at an instant. That's why we've learned derivatives. So keep that in mind. So if s of t stands for the position function, the derivative of that is our velocity function. Okay, and then if the absolute value of velocity is the speed function. So think about like your speedometer. It's not telling you where you're going. You know where you're going. It's a speedometer. It's just telling you the absolute value of the velocity. Okay, so important thing here is your direction. If you have a positive velocity, that means you're moving to the right. So I think about it like you're walking along a number line. And I'd be walking in front of the class if we were in person right now. So you're starting here. If you have a positive velocity, you're moving that way. If you were talking about moving up and down a y-axis, you'd be at 0, you'd be moving up. Versus if you have a negative velocity, even though I'm here, say my velocity changes, I then move that way, that would be a negative velocity. Or I start moving down. So position of a free fall function, this is not something that you really need to memorize. I will give this to you because it's going to, problems that I'm going to give you inherently are going to give this to you in the problem. You need to know these two things, but it's going to be given to you in the problem. So I wouldn't worry too much about it, but understand that this is physics that we're doing right now. So if you're in physics, then you need to understand that this is all plays into what you're going to be doing in your physics class, okay? Okay, so this first example. Ball is dropped from 100 feet. Ball's height at times t is given by this function. If you think about it, starts at 100 feet, moves along, its initial velocity is 0 because I'm just standing on top of a building and dropping it. Anyway, I just wanted to show you guys that the formula actually works out. Find the average velocity over each one of the time intervals. So I'm going to find s of 2 minus s of 1 all over 2 minus 1. And that works out to be 36 minus 84 all over 1, which simplifies to be negative 48. If I give you units, give me units back. I'm looking for my units, feet per second. If you're in physics, you guys are usually pretty good about that. Next, you have s of 1.5 minus s of 1 all over 1.5 minus 1. And I work this out, it ends up being 64 minus 84 all over 0.5, which works out to be negative 40 feet per second. Okay, the next example. Diver jumps from a platform that is 32 feet high above the water. Initial velocity of the diver is 16 feet per second. So this uses that formula. I will give you this formula. Some of you may know it from physics, and that's great. But I will give you the formula. I'll probably say something like his position at any time is given by this formula. So when does the diver hit the water? Well, let me first get my equation here. S of t, my initial velocity, since I'm talking about feet per second, that's 32 times 1/2 ends up being negative 16 t squared. My initial velocity is 16 t, and my initial height is 32. So when does the diver hit the water? So I solve this. This is actually one of my favorite questions in my Algebra 2 trade class. So I always like to factor out the negative 16. I have the answer incorrect in my notes. 32. So now there's factors. It is not 32, Mrs. Marnell. Get it together. So it is t minus 2, t plus 1. So my times are 2 and negative 1. We do not have a time machine, so we ignore the negative 1. So our answer is 2. What is the diver's velocity at impact? So my velocity, I have to find the value of the velocity, which is the derivative of position. And so that is negative 32 t plus 16. And I'm trying to find this at 2. So I do negative 32 times 2 plus 16. And that ends up being a negative 48 feet per second. Okay. So that is your video. I know that was kind of a hefty one, but there's lots of information in there, lots of good stuff. That's all I got. Thank you very much.